Hello everyone, Nucleus here, back with another video. So initially what my plan was for the going over the internals of the build guide was to purchase all new parts and kind of walk you step by step through the building process, uh, motherboard nomenclature, and the nomenclature of all the different parts that are going to be used in the board. And then I realized I still had, uh, well, not quite a finished computer sitting on hand, but I still had a motherboard, CPU, and cooler sitting on hand, just sitting around doing nothing. So instead of um, buying all new parts, even though I'm kind of in the middle of two builds right now, I thought it would be better to kind of go back and upcycle this motherboard. And actually, I did get a new CPU for it and new RAM, but um, here it is. So, so if for those of you who remember my very first video, uh, this was my old gaming PC. I can show a picture of what it originally looked like because I had the Dreambox that I'm using for my water cooled build uh, set up into like a test bench configuration. And so with that, I had or I do, well, it's still in there, a 2600X CPU, um, and I still have um, the Cooler Master 620A, or the Cooler Master Air 620A dual tower cooler, which would be for the AM4 um, AM4 platform or AM4 configuration. So here we're going to kind of show you the difference between this board and this board, which is so this is a Aorus X670. I believe this is X670E. Yeah, it's Aorus 8670E Elite Wi-Fi. So this is going to be for the Ryzen 9 series, while this is for, or sorry, Ryzen 9000 series. While this is for the AM4 platform, this was at least with this particular chipset, this is an X470 Gaming Plus motherboard. This was the generation before for the final generation, before the Ryzen 7000 series, which is the first generation of the AM5 platform. So I know it sounds like I'm speaking Greek to you and whatnot, but it's really important because as you'll see with this CPU and what is supposed to be here in this CPU, there's a significant difference. So let me open up the retention bracket. Oop, there we go. So what you see here is kind of reminiscent, if you haven't looked at a motherboard for Intel, in that this is called, or the way that the CPUs are going to be, you have two kind of configurations. You have land grid array, and you have or LGA or pin grid array, PGA. So in here, what you're looking at is these are the pins, and on the bottom of the 7000, 8000, and 9000 series, they're going to be like a series of pads or just contacts. with this CPU and others like it. This is PGA, and all these are different pins that socket into these different slots. And that's going to be the major difference. So I'll put this back in. Drop it in. And so that's why I'm also going to go back over the PC part picker page and show you the importance of that compatibility checker for that website.
Here's our blank parts list on PC Part Picker, and we're going to show their compatibility tool in action in real time. Starting from the top with the CPU, I'll do a search for our CPU, a Ryzen 5800X, then add to our parts list.
So what I have here is a Ryzen 5800 CPU. This is the Zen 3 architecture, and then we'll just use this for the compatibility checker between being used in our X470 Gaming Plus and our X870E Elite Wi-Fi.
So we're going to add the X870E motherboard to our parts list so we can get the compatibility checker to kick back an error about our CPU not being compatible. This is interesting. The site's compatibility checker seems to already be working. I can't add the Elite Wi-Fi 7 motherboard to our parts list. Let's try adding the motherboard first, then the CPU. Alright, X870E Gigabyte Elite Wi-Fi 7. Now we'll try to add the 5800X, and it looks like we can't. So the compatibility checker is always active. I didn't know that. That's amazing. So we'll go back to our 5800X CPU, AMD Zen 3. Next we'll add our MSI X470 Gaming Plus motherboard. And as you can see from the compatibility checker, we have an error that says we need to update the BIOS for 5800X to be compatible with the X470 Gaming Plus. That's not a big deal. MSI has a tutorial on their YouTube channel on how to update their BIOS.
So with our motherboards here, you're going to kind of see. Generally, they're all pretty much the same. So you have the socket where the CPU goes. You have the RAM slots on both. So you might not be able to see it on here very well because of the heatsink and I/O shroud. But here, these connectors here in the corner, top left, are your EPS power connectors, and what those do is they provide power from your power supply to your CPU. This section here is also part of the power delivery system for the CPU. As you can see, there are inductors and capacitors that make up the power delivery system with regards to delivering power to the CPU. It also kind of cleans up the DC power coming from the power supply. So the power supply, when we get to that part of the, you're building for the first time, it is meant to turn your grid power or power that's coming from the electric company through your wall outlet into DC power. So that's a lot of complicated electronics and electrical stuff, but that's going to be what the power supply does. So the thing is, especially, so now you have these heat sinks. These are aluminum heat sinks, and kind of what their, well, not kind of, what their purpose is is to absorb the heat from the inductors or chokes and dissipate it out into the case, into your computer case. Um, so you have a similar power solution here. Let me see if I can maneuver the motherboard a little better. So unlike the MSI board, which has a split 8-pin connector, you have dual 8-pin connectors here. The power delivery system is significantly more robust, which also owes to the fact that this is a higher end motherboard and is meant for overclocking. So you can see that the power delivery system is significantly more robust. The heat sinks are more robust because this board is quite heavy. If you could feel it right now. And we've already talked about the difference in the socket. So that's going to be so looking at your the differences in your motherboard, especially when you're thinking about things in terms of quality. Definitely, you're going to be looking at how robust your power delivery systems are, the size of the heat sinks used to dissipate that heat from your power solution. Other premium features, just so you know that this is a high-end motherboard, is that you have a integrated input-output shroud. This plate usually would come separately from, well, it would come with the motherboard, but wouldn't come already fitted on. Unfortunately, for this one, owing to the fact that this was, I believe this was a mid-range board to budget board, the IO shield is not integrated. In fact, the IO shield for this has been lost to the ether. But that that shows you like the premium or the quality. No, I shouldn't say quality, but the tier of motherboard in which you're operating with. So yeah, it's pretty different. So moving on. So we've already talked about the EPS power connector for this for the CPU. You have your 24 pin motherboard connection. That's also coming directly from the power supply. That is supplying power to pretty much everything else on the motherboard that isn't the CPU. If I remember correctly, with the new generation of Intel processors, the Arrow Lake CPUs, the CPU itself not only gets power from the EPS power connectors, but also from some of the some pins on the 24-pin power connector, something that Intel engineered. You can go see the Gamers Nexus video with regards to their benchmarking of the new Arrow Lake CPUs. So down here you have the actual chipset. So this is the hardware controller. So it's going to be controlling other parts of the motherboard. This does electrically does connect back to the CPU, because the CPU will be talking back to your hardware controller and vice versa. We have and it's pretty much the same for the Elite Wi-Fi 7. Under here is the chipset. This is a heatsink, as with this here, so that anything with that has electricity flowing through it generates heat. So So now you have. Now we're going to kind of get into some of the like really big differences. They don't necessarily appear uh, obviously, but they are significant differences. So right here we have the M.2 slot. We have one here for this motherboard. And so if you were to look at this casually, you'd think, okay, they're all the same. The difference is that even though they pin out generally the same, they're significantly different. So in the case of this one here on the Aorus motherboard, this is PCIe Gen 5, which is the new PCIe standard. So it's all about faster data transfer speeds. This one here on the X470 motherboard, this is PCIe 3.0. So it's not going to be anywhere near as fast as this one. Under here, this heatsink, same thing, 3 M.2 slots, but these are PCIe Gen 4, which is a significant difference. Still faster than PCIe 3.0, but slower than 5.0. And here the MSI motherboard only has 2 loose slots. So also kind of point out, and that's going to be kind of a quirk with regards to working on this motherboard, is that when you have these 2 M.2 slots occupied, they actually shut down the SATA ports. It will shut down SATA port 1 when you have M.2 1 slot filled, and SATA port 6 when you have this second one occupied. So, and that was this was still the M.2 standard had been around for a little while by the time I had got to this, but M.2 drives were prohibitively expensive at the time. So it was, you would see people who, well, one who could afford it use it, or people who needed fast data transfer rates get M.2 drives, and probably some other situations as well. Speaking, and since I did kind of mention them also, the SATA ports, these are SATA 3 or SATA generation 3. They do offer data transfer rates at 6 gigabits per second. The same is for this motherboard as well, except as opposed to the 6 on the MSI board, we have 4, and that's primarily probably because with the cost of this motherboard, they're probably expecting people to most likely utilize all the M.2 slots. So, and we kind of saw it on this one, but I'll show it on some first. This board connector here, that is USB 3.0. It does have, this is one header, and this is the second USB 3.0 header. And what you have here on the Elite Wi-Fi 7 is one USB 3.0 header right there, or might be USB 3.2, a second USB 3.2 here, and if you're very curious, or if you kind of notice this. This is also USB 3.0 or USB Gen 3, but this is for the USB Type C connectors. So totally different connector on the front panel. You've probably seen it on um, charging charging bricks for your cell phone. That's what that connector, at least on the motherboard side of a CP, on a motherboard side of a computer, looks like. And so now we'll get into the expansion slots. Uh, these are all um, PCIe Gen 3, an older standard. Not nearly as fast as what's over here. This definitely is a PCIe Gen 5. So you're talking about faster data transfer rates between your expansion cards. I believe these are either 4.0 or they are 5.0. PCIe 4. So these two are PCIe 4.0. So another thing that you're probably noticing is these smaller PCIe slots here and their absence here. So these are PCIe Gen 1 expansion slots. And at the time, and especially if you go back and you at least look at the picture of this particular build I did have um, a wireless NIC in one of these slots. And that's kind of what these were for. They're for like add-in cards, like your sound card, your Wi-Fi card. Maybe you had a wired Ethernet card, but these were not particularly fast, and really all they were is more for accessories as opposed to something. They required a lot of bandwidth to talk between the expansion slot or the device connected to the expansion slot and the CPU. On the rest of the board, you have a bunch of different headers. So these down here that are kind of clearly marked as USB, these are USB 2.0 headers. Here is your front panel connector. These are going to go to connect to the buttons on the front panel of your CPU on your computer case. So your power button, your reset button, hard drive activity lights, hard drive hard drive activity. Your power indicator as well, because some buttons on the cases have the integrated power on light. This is, I don't remember what this particular header is for. This is for a COM port. For a lot of the old motherboards and older computers, this COM port is how you would connect through a there's RS. Well, it was a serial port connector. I believe it was RS-232. 232 port. That meant you were communicating with a device. Typically, a lot of times it would be like a network device that used a serial connection to communicate between the computer and that device. This is the clear CMOS button. So in the case of the CMOS, so what that refers to is the BIOS or the firmware on the motherboard itself. This is the CMOS battery. So it's kind of helpful in that case, because that with CMOS, or at least with people who do overclocking, um, with the way overclocking is or was then, as opposed to, well, it hasn't really changed. But what the clear CMOS did was, if you did some overclocking, and for whatever reason the overclock that you put on your on your CPU caused some sort of instability issues, coupled that with the fact that with the M.2, because they're not like the mechanical hard drives and they're all chip based, uh, they would boot up extremely fast. So if you had issues with the stability of your overclock, what you could do is you could hit that CMOS, clear CMOS button, or remove the CMOS battery, and that would clear out any changes you made in BIOS, and then you'd have to start over again. It wouldn't brick your motherboard. It would just take it back to the default factory settings. Excuse me. Here, and I wish they kind of did. Here, this is your front panel audio. If you can see the outline here, that shows what the audio solution that's built into the motherboard. As you can see, it's not particularly robust. Unless you're getting into music production or something, you're probably gonna have an external sound card. But the onboard motherboard audio solutions have gotten better over the years. So some more important things, and I probably should have kind of gone with that, is these headers here, these 4-pin headers with this little plastic tab. So you use that to control your CPU fans, or I shouldn't say not just your CPU, your CPU fans. That's incorrect. They control the any fans that are connected to the motherboard. As in, like, this one is marked as CPU fan. So when you see the cooler mounted on, you'll see one of the connections going to this fan header. There are 1, 2, 3, 4, 5, and 6. And the reason why there are 4 pins is because one of the pins is dedicated to varying the fan speed. So, and that's usually dictated by CPU temperature. There are 3-pin fans out there. They're called DC fans, and the thing about DC fans is that they just run at 100% all the time, no matter what. Whereas having these 4-pin fan connectors, you can either control the speed manually, or it can be adjusted based on what's going on with your CPU. In the case of at the time, I did not have an AIO, or a water cooled solution connected to it. But as you can see, that this one here is marked pump and fan, and really all it is that they use the same type of signaling. So you could potentially plug your pump into any of these headers, depending on how close or how long the wire coming off of your pump is. So that's it. With this also, you have a separate 4-pin connector. These are RGB, and of course RGB is for red, green, blue, for controlling lighting solutions on your various aspects of your case, like lights within your fans, LED lighting strips, that sort of thing. So this one only has two RGB connectors, or RGB headers, one here and one down here. And so even though I've neglected the AORS motherboard, same thing, 4-pin headers. Of course, this gray one here, gray color one, probably meant for your CPU pump, but the signaling for your fans and your AIO solution or your water pump, it's going to be the same. So this one has 1, 2, 3. 4, 5, 6. And that's it. One thing you'll also notice is these 3 pins. So as you can see, it resembles a 4-pin RGB header, but what this is a RGB. So this is addressable red, green, and blue, and that is for when you want to get into like really customizing your lighting solutions. Whereas opposed to the RGB, you were pretty much limited to red, green, and blue. You are capable of accessing like the entire spectrum of colors, and usually they have like a when you get into some of the current day accessories, they have their own lighting solutions, or they have some software that allows you to control your lighting solutions. Color scheme, animation sequences, and whatnot. Unlike the other motherboard, our X470, there's some other things in here that are pretty unique. So these are actual. This is the power button, and this is the reset button. So this still does have the same front panel headers, but the reason why these buttons are included is if you were to use this motherboard as a test bench, you wouldn't have to put it in an actual physical case. You could use a special test bench case, which is basically just an open top case. You plop the board down, hook up all your connectors, and instead of having to hook up an external power button, your power button's already integrated into the motherboard. This LED readout displays various codes that are that come with, or I should say, that basically explains what your motherboard is doing at the time, whether it's posting or there's some sort of error. If you ever need to know what these codes mean, they're typically going to be inside of the owner's manual for the motherboard itself. Is there anything else pretty much about the board? So we did talk about ARGB. ARGB headers, you have one here, 2, 3. And then you have a normal or an RGB 4-pin header right there. 2 USB 2 headers, the front panel audio, so these small pins, I'm not exactly sure what they are for. I never had to use them before, and I have something similar on the other motherboard as well. So also with this motherboard, it has a integrated HDMI port, which is kind of owing to the high-end motherboard, high-end nature of this motherboard. If you've ever seen the Height Y70, there is a separate screen in which you can buy for that you can hook directly to your motherboard. to use as a separate display, kind of part of the just customization of the case. Kind of a gimmick, but you know, it is what it is. So, rear panel. So, with this motherboard, we have 4 USB Gen 2, 1, 2, 3, 4, 5, 6 USB 3.2 Type A slots, HDMI, connector, and these are 2 USB Type C, but these are of USB 4.0 standard, so they're going to be faster data transfer rates than USB Gen 3. We have our Ethernet connection. This is new. I believe only Gigabyte has done this so far, as opposed to screw terminals for their Wi-Fi antenna. You just plug in a single connector, you're good to go. Audio outputs. This is optical for those who have high-end external audio systems. Mic and line out for your speakers or your headset. So totally different here. So this is a PS2 port. So this is a pretty old connector, mainly used for keyboards and mice. There are still some of these connectors out there for keyboards and mice out there. I haven't seen them lately, but they're still out there. You have 2 USB Gen 2 ports. This is an DVI-D video connector. This was just prior to the HDMI. We have our HDMI connector. 1, 2, 3, 4, 5, 6 USB Gen 3 Type A connectors. Our Ethernet connector. Our audio solution. Of course, we have the optical. I don't remember what the configuration for these are, because they're labeled on the the rear IO shield, but I believe that it's going to be pretty much the same with that. This is going to be your mic. This is going to be your line out, so for your speakers or your headset. I believe these though are for when you start integrating surround sound systems that aren't on an optical using the optical solution. So, and that's kind of going to be it for a tour around the motherboards. And oh, I forgot to mention. So yeah, we have the CMOS battery here. The CMOS battery for this is most likely going to be under the heatsink for our chipset. So that's there. And I forgot to mention down here are front panel headers. So sorry about that. So that's going to be it for the Wi-Fi 7, and we're going to focus in on our gaming, our X470 Gaming Plus motherboard. So I'll button this up, and we'll continue from there. Okay, getting back to our Gaming Plus motherboard. So we're going to go ahead and just making sure there's no damage to the 2600. Okay. So we're going to go ahead and we're going to install our Ryzen 7 5800X. 8 cores, 16 threads, PCIe 4.0. Awesome. So the big thing about this is, and I think you should also kind of, I'd hope you go back and check the video for my gaming build that supplanted this one, which used a Ryzen 9 5950X. The 5900X was the flagship of this generation, and but the 5950 was kind of a Halo product because of its specs. So 5800X, a little case badge. So one thing you have to kind of understand when installing these CPUs, whether it's Intel or Ryzen, make sure that you're installing them completely. Or, sorry, completely. Yes, completely, but correctly. So here on the socket, or I should say right here, you see this white dot here, and and sometimes you'll see it somewhere on the socket as well. There will be a indicator telling you in which direction you need to install the CPU. So Intel CPUs and now the newer Ryzen CPUs, they're notched on the outside perimeter somewhere on the CPU, so you know when you're installing it correctly. In the case of this is basically telling you the orientation of the CPU. We have this kind of indicator here. Actually, that's not correct. Right here, this indicator right there, that triangle basically tells you the orientation that the CPU needs to go in. So you basically just have to match it up, because if they don't match up perfectly and correctly, your CPU won't go in. There we are. That is the locking mechanism, totally different from the retention bracket of the AM5 and Intel's CPUs. So it's pretty much secure. So now comes the part that's very important, and that is the securing of the cooler to this CPU. So and maybe I should have gone over this before, but it kind of is worth mentioning now. So what you're looking at as far as the CPU is not the CPU. This is called the package because it is the total CPU. What this is here is the integrated heat spreader, or IHS. Beneath this cap, beneath this heat spreader, is the actual CPU itself, the actual processor. But everything that you're seeing here in totality is called the CPU package. So, as that goes through, processes data, does calculations, it's going to get hot. That heat will spread from the CPU to the IHS, and that's where your cooler comes in, because the cooler is going to make contact with the IHS and is going to transfer that heat away from the CPU into your case, and then your that cooler has to also get cooled somehow, because you don't want it to just do more than just absorb heat. So this is the Cooler Master Master 620A. As you can see, it is a dual tower cooler, just like the Dark Rock Pro 4 that I used in my last gen gaming build video. But it's also dual tower configuration, like the cooler, the Deep Cool dual tower cooler that I used in the CPU that I built for my the computer that I built for my brother. So how this works is, so these are all heat pipes. I believe in the case of these, there's a small amount of liquid in the heat pipes. This flat part goes on top of the IHS. Heat from the CPU through the IHS goes into here. It heats up the liquid to transfer that heat away from the CPU and into your fin stack or fin array. The fans will then blow air to cool off your fin array or the cooler, thus getting that heat away from the CPU and into the case, and eventually out of the case through an exhaust fan. So with this, it will, because I've already got everything pre-mounted, will go on like that. And of course, then we plug in our fans. Don't worry, I do have the clips for these. We were plugging our fans, screw the tighten, put the nuts down on these to tighten it down, and we're good to go. So, but that's not how this works entirely, because what we have to do is we have to put some thermal paste on top of the IHS, which is also going to help facilitate that transfer of heat from the IHS to our cooler. So give me a second. I've got a ton of thermal paste kind of lying around just from years of building CPUs. So give me a second. Well, actually, we might as well do this first. So because of the size of this cooler and the need for tightening down, because I have to actually use a wrench because there are hex nuts to tighten down, I will have to remove this heatsink. And that's, pretty simple. It's just some screws on the back of the board. But we'll get to that. Alright, so I've got some Noctua thermal paste. This actually came with a low profile cooler that I used in a separate build, but we can still use it because I believe with this amount, I think I bought this separate from that cooler, to be honest. Anyway, let's go ahead and remove that heatsink before we get started mounting the cooler. And all this is just 2 screws. Voila. Okay, so we're going to apply our thermal paste to the IHS. So, back in the day, the rule of thumb for applying thermal paste was to use a pea-sized shape or rice grain, depending on who you asked. There are a couple different ways of applying thermal paste now. Some coolers include a spatula. Some will include a stencil where you just apply the paste, remove the stencil. Typically, it's already taped onto a cooler, and then you just start mounting it. So. And the act of mounting the cooler on top of the CPU will kind of help spread that thermal paste around. So what I'm going to do now is I'm going to go ahead, I'm going to start applying the nuts to the mounting bracket, but for a special note, when it comes to mounting a cooler to your CPU, or no matter what brand it is, or whether it's an AIO or an air cooler like this, is that when you actually tighten it down, you're going to go in a cross pattern or an X pattern, so corner to corner. But since we're just hand tightening these down, we're not going to worry about that until it comes to actually tightening down tightening them down finally, or for finality. And the reason for that is if you tighten down one side too much, or any one side too much, you won't be able to actually mount the cooler properly, and because one side will just be so tight that one side won't be able to be mounted because just the pressure is applied unequally. Like that. But we're still connected. All right, now we're going to tighten down in our cross pattern. And it kind of doesn't matter where you start, as long as you as long as you stay consistent. All right, now that we've got the cooler seated, as you can see, you can I can pick the motherboard up by the cooler. So that means this is firmly mounted. Everything should be kind of even. The pressure should be evenly distributed across the motherboard and across the CPU. And so I will actually before I actually clip on this fan, we're going to install our RAM. So for this build, I went and, much like getting a brand new box CPU, I went and decided to get all new RAM as well. And so I will be using the Ripjaws from G.Skill. This is a DDR4 And I kind of failed to mention that the X9, X9, X870 motherboard will be is using DDR5 memory. So this is a 64 gig kit, but the DDR4 memory is going to be slower than DDR5. This kit is 3200 mega transfers, whereas the X870 motherboard and even the previous generation, the X780, can go up to 6000 mega transfers uh, per second. So you're talking about, faster versus slower memory, newer memory, standard as well. So we're going to kind of be offsetting the slots. So one thing to be sure is there's only one way to install your RAM. The RAM slots, well, if you feel the need that you have to really force your memory into your RAM slot, it's because you're probably doing it wrong. Plus, as you can see within the RAM slots, there are notches that are meant to match up with the notches on the DIMM sticks as well. So, and then when you give it a little push, these retention clips, you can say, will snap in automatically, so you don't have to push down on them manually. Yep, there we go. And we'll do, so we got 64 gigs of DDR4 memory in here. We will mount our fan, and then we will mount the our heatsink back. Mounted in the wrong spot. And it helps to put them on correctly. There we go. Okay. right, now with the fans properly mounted, and I think I should show you this. Um, so when it comes to coolers like this, these dual tower coolers, you definitely want to make sure that you have clearance for your RAM. Some of them have really tall heat sinks. If you ever, I don't have any DDR4 Dominator Platinum from Corsair to show you how high those heat sinks are. Those are huge. But definitely when it comes to looking at coolers like this, definitely check your RAM height. There are some low profile RAM sticks that have smaller heat sinks. So I have some Corsair Vengeance, and as you can kind of see, well, it's better to do it this way. The height of the heat sinks is slightly smaller, but some Dominator Platinum, especially the RGB variant, the heat sinks are pretty tall. Okay. So with that, I'll screw down the VRM heatsink, but really there's nothing else left to do for this particular entry in the video. Stay tuned for part 2, and we'll go over storage for this motherboard and different storage solutions. So thank you for watching. Please comment, like, and subscribe, and I'll see you in the next video. Bye.